Once upon a time, 13.8 billion years ago, a cosmic spark ignited the beginning of an epic story. This is the tale of the universe, a grand symphony composed of energy, matter, and time. As Carl Sagan once said, the cosmos is all that is, or ever was, or ever will be. In the beginning, there was nothing. No space, no time, just an infinitesimally small and infinitely dense point called a singularity. In a split second, this tiny speck burst into existence, expanding rapidly into what we now call the Big Bang. Albert Einstein's groundbreaking theory of general relativity offered us a mathematical framework to understand this awe-inspiring event. It's important to note that the Big Bang is currently the most widely accepted scientific theory for the origin of the universe, though other theories and ideas exist. During the first 10 circumflex 43 seconds, known as the Planck epoch, the universe was so hot and dense that our current understanding of physics can't describe it. The reason for this limitation lies in the fact that at such extreme conditions, the four fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces, are believed to have been unified into a single force. As the universe expanded and cooled, it entered a phase called cosmic inflation. This period saw the universe grow exponentially, stretching and flattening space in the process. Cosmic inflation solved the horizon and flatness problems that had long puzzled scientists. The universe began its expansion as a hot, dense, and uniform mixture of particles and energy. At this stage, it was so hot that particles of matter and antimatter were constantly being created and annihilated, leaving behind photons, the particles of light. When an electron at rest annihilates with its antimatter counterpart, a positron, the process results in the emission of two photons. As the universe expanded and cooled, it reached a critical point where the particles of matter triumphed over their antimatter counterparts. Within the first second of its life, the universe was ruled by the fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces. Richard Feynman, the Nobel Prize-winning physicist, famously described these forces as the great principles that everything is made out of. During this first second, the forces underwent a series of symmetry-breaking events, separating from one another and taking on their distinct characteristics. Symmetry breaking is a phenomenon where a disordered but symmetric state collapses into an ordered but less symmetric state. As the universe cooled further, quarks, the most basic building blocks of matter, combined to form protons and neutrons. These protons and neutrons would eventually come together to create the nuclei of the first atoms. This period, known as nucleosynthesis, lasted for about 3 minutes and resulted in the formation of hydrogen and helium, the two lightest elements. Approximately 73% of the mass of the visible universe is in the form of hydrogen. Helium makes up about 25% of the mass, and everything else represents only 2%. For the next 380,000 years, the universe continued to expand and cool. It was filled with a dense fog of charged particles, preventing light from traveling freely. But as temperatures dropped, protons and electrons combined to form neutral hydrogen atoms. The universe became transparent, and photons were free to travel across the cosmos. This moment marked the birth of the cosmic microwave background, a snapshot of the universe's early light that is still visible today. The cosmic microwave background is not uniform, but contains tiny fluctuations in temperature and density. These fluctuations, imprinted on the cosmic microwave background during the era of cosmic inflation, serve as the seeds of cosmic structures. They hold vital information about the composition, age, and geometry of the universe, allowing scientists to probe the nature of dark matter and dark energy. Over the course of millions of years, small fluctuations in the density of matter began to grow under the influence of gravity. These fluctuations eventually led to the formation of vast cosmic structures, galaxies, stars, and planets. Within these galaxies, immense clouds of gas and dust collapsed under their own gravity, giving birth to countless stars. Some of these stars were colossal, their cores fusing hydrogen into helium and releasing tremendous amounts of energy in the process. These massive stars lived fast and died young, exploding in violent supernova and spewing their enriched guts back into the universe, seeding the cosmos with heavier elements like carbon, oxygen, and iron. These elements are the building blocks of planets and life as we know it. Out of this cosmic debris, new stars and planetary systems formed, including our own solar system. In the words of Carl Sagan, we are made of star stuff. The elements that make up our bodies, the Earth, and everything on it, were forged in the hearts of ancient stars. Over the next 4.6 billion years, our planet evolved, giving rise to oceans, continents, and eventually, life. The early Earth was a hostile environment, bombarded by asteroids and comets. But through processes not yet fully understood, simple organic molecules formed in the primordial soup and eventually gave birth to the first living cells. These early cells were prokaryotes, simple organisms without a nucleus. They thrived in Earth's oceans, slowly transforming our planet's atmosphere by producing oxygen through photosynthesis. Over time, more complex cells called eukaryotes emerged, paving the way for the incredible diversity of life we see today. Throughout Earth's history, life has taken many shapes and forms, from single-celled organisms to complex multicellular creatures. Life has faced numerous challenges, such as mass extinctions and dramatic climate changes, yet it has persevered, adapted, and flourished. Great thinkers and visionaries throughout history have pondered the universe and our place in it. Isaac Newton, a pivotal figure in the scientific revolution, once said, "What we know is a drop, what we don't know is an ocean." His work laid the foundation for our understanding of gravity and motion, allowing us to peer into the vastness of the cosmos. As we ventured into the modern era, scientists like Edwin Hubble uncovered evidence that our universe was not static, but expanding. Hubble's observations of distant galaxies revealed that they were moving away from us, suggesting that the universe had been smaller in the past. With each passing decade, new discoveries have shed light on the universe's remarkable history. Satellites like the Hubble and James Webb Telescope and the Wilkinson Microwave Anisotropy Probe have captured breathtaking images of celestial wonders and given us a deeper understanding of the cosmic microwave background, the afterglow of the Big Bang. Today, we stand on the shoulders of giants, gazing out into the cosmos and seeking answers to some of the most profound questions. How did the universe begin? What is its ultimate fate? Are we alone in the vast expanse of space? As we continue to explore the universe, we are reminded of the words of the late Stephen Hawking. Remember to look up at the stars and not down at your feet. Try to make sense of what you see and wonder about what makes the universe exist. Be curious, and however difficult life may seem, there is always something you can do and succeed at. It matters that you don't just give up. As we continue to unravel the secrets of the cosmos, we celebrate the ingenuity and curiosity of the human spirit, and we are humbled by our place in the grand tapestry of existence. For, as Carl Sagan once said, we are a way for the cosmos to know itself. We peer into the distant reaches of the universe through ever more powerful telescopes, searching for clues about the nature of dark matter, the mysterious substance that makes up about 27% of the universe's mass. Invisible to the eye, dark matter's presence can only be inferred from its gravitational effects on visible matter. In the words of the great physicist and storyteller Richard Feynman, the imagination of nature is far, far greater than the imagination of man. As we journey through the cosmos, we are constantly reminded of the boundless creativity of the universe and our own capacity for exploration, curiosity, and wonder. Together, we embark on this grand adventure, writing new chapters in the epic tale of the universe and our place within it. If you enjoyed this video, we kindly ask you to hit that like button, share, and subscribe to our channel for more captivating content. Your support fuels our passion for exploring the potential of AI-generated content into the future. We encourage you to support our Patreon to help make this possible. Until next time, keep questioning, keep seeking, and never stop exploring the boundaries of your imagination. Thank you for watching.